Assalamualaikum warahmatullahi ta'ala wabarakatuh to everyone that is watching this video right now. My name is Muhammad Shamil bin Muhammad Zaini and I'm currently studying at UTM Johor Bahru. My matrix number is 821EM0299. So for today, for our team, we got the topic of cofactor expansion, one of the subtopic in the matrix and under the topic of determinant, right? So cofactor expansion, and the first thing, I will be the first person to tell you about the formula we are using in cofactor expansion. Actually, it's not that quite different from cofactor itself. We're still going to use the formula that you learned from cofactor, which is Cij equals to -1i plus j determinants Aij. This is a very common formula for cofactor. So what does mean by expansion? So to find a determinant like matrix 2 by 2 or 3 by 3, you still can find determinant using the basic way step to calculate it. But how about for the kind of matrix that is in a huge number, let's say 10 by 10, 30 by 13, 24 like that. So it's going to be hard if you want to calculate. You can still calculate it by the basic step, but it's going to take a long step and very hard one. You will probably make a mistake. So by using cofactor expansion, you can find the determinant of any numbers of matrix by using either 2a's, which is from their column, or from the row. So let's say by the column, you got determinant A is equal to A1j times with A1j plus A2j and A2j plus and continue so on. So this is the formula for the column. Actually, it's not that quite different from the row formula, which is here. You can see that this part, if you're trying to think what is this Aij means or what is this Cij. So this is actually quite the basic things, is the same things, which is this formula again. So this is the basic equation in cofactor expansion. Like I said, it's not so much different from the cofactor formula itself. This is the basic one, just we're going to use it to expand in the formula, whether you want to choose from the column side or the row side. So let's take an easy example to show you how this formula works. But let me find where's the dust.
Hi, my name is Tengku Siti Batusha and I'm from Group 5. My matrix ID is A21EM0241. Here, I will show you how to find the determinants using cofactor expansion by row. As you can see, we have a matrix of A which is equals to 1, 2, 3, 0, 1, 4 and 5, 6, 0. To expand this, first we choose one row. We can use any row. It can be this row or this row or this row. Let's choose this row to expand. And I will take this number 1, then I remove the row and also the column. Then I will end up with this 2 by 2 matrix, which is 1, 4 and 6, 0. The next element will be minus. Next element is 2, remove the row and also the column. Then we will have the matrix 2 by 2 of 0, 4 and 5, 0. The last element is 3, remove the row and the column. And we will get positive 3 with the matrix of 0, 1 and 5, 6. To simplify it, we times 1 with the determinants of the matrix. And the determinant of that will be 1 times 0, which will get 0, and that will be minus with 4 times 6, which is 24. The next element is negative 2, and we'll times with the determinant, which is 0 times 0, we'll get 0, minus 4 times 5, we'll get 20. Next is positive 3 and times with the determinants of the matrix, which is 0 times 6, we got 0, and then we'll minus with 5 times 1, we'll get 5. Then we will solve this, we will get negative 24 plus with 40, and then minus with 15. Finally, the determinant of A we will get is 1.
Assalamualaikum and good morning to those who seeing this video. My name is Nofasem Uze and currently I'm studying in UTM's Kudai Johor as a student in mechanical engineering. As the third representative in my group, I would like to explain an example about how to solve matrix problem by using column. Right, this is one of the example of question that I could find to solve matrix problem. Okay, it said that we could find the determinant of a 3 by 3 matrix. Okay, we could solve the 3 by 3 matrix by using cofactor expansion. Okay, as I said that we will use columns to solve this problem. So there's 3 columns on the 3 by 3 matrix. So I will use the first column to solve this equation, which is 4, 5, and 6 to be multiplied with the determinant of the 2 by 2. And with that, we have the alternate positive, negative, positive to solve this equation, right? And then we use the determinant of the first term, which is 0,719. The second term that will be multiplied with 5 is 7,319, and the third terms, which is 6, will be multiplied with the determinant of 7,307. But how do I get the determinant of the 0,719 to be multiplied with the first term, which is 4? Okay, because the first term, which is 4, we will cross over the horizontal and the vertical line of the first term, and the remaining that we did not cross over will be the determinant of the determinant that will be multiplied with 4. But to make it easier for you to understand, I will make it in the ABC terms, which is the cofactor of B equals to A with determinant of CBDE, and the A will be multiplied with the C multiplied with E times with D multiplied with B. We can see that this is a crossover multiplication. Alright, let's continue with the solution of this equation. Cofactor B is equal to 4 times with negative 7, negative 5 times with 60, and 6 will be multiplied with 49, and we will get negative 28 minus 300 plus 55, and the solution of the equation is negative 273, and this is how you could find the solution by using column.
Assalamualaikum and a very good day. My name is Amira Iliana and today I will be presenting another example of question regarding this topic. Here it shows that with a minimum of computation, we want to use the cofactor expansion method to find the value of the determinant of matrix A. Notice that matrix A is a 4 by 4 matrix. So, to minimize the number of computation required by the question, we will be using the row with the most zeros to form the cofactor expansion. we will use row 3 to form the cofactor expansion. So the determinant of matrix A is equal to, now using the row 3, the first element is 6. So we will have 6 times the cofactor, and according to the cofactor formula, this 6 is in row 3, column 1, we would have 6 times negative 1 raised to the power of 3 plus 1 times the minor. To form the determinant, we will eliminate row 3, column 1, which will give us a 3 by 3 determinant. And the elements will be 0, 0, 2, 4, negative 7, negative 5, negative 2, 3, 1. Now, from here, notice how the remaining elements in row 3 are 0. So, we would have plus 0 times the cofactor. So, notice how these products will be 0. Next, the determinant of matrix A is equal to, well, here we have negative 1 raised to the 4th, which would be positive 1. 6 times positive 1 is 6. So, we would have 6 times the value of this 3 by 3 determinant. Again, let's use cofactor expansion and notice how row 1 has 2 zeros. So, we will form an expansion using the first row. We will have 6 times the value of this determinant. So again, using row 1, we would have 0 times the cofactor, and we already knew that it is equals to 0. And finally, the last element in row 1 is 2. So we would have plus 2 times the cofactor, which would be negative 1 raised to the power of this element is in row 1, column 3. So we would have negative 1 raised to the power of 1 plus 3 times the minor, which is, in this case, will be the 2 by 2 determinant formed by eliminating row 1 and column 3. So we were left with a 2 by 2 determinant. So where the elements are 4, negative 7 and negative 2, 3. So to simplify, we are going to have 6 times 0, 0. And here we have negative 1 to the 4th, that's positive 1. So 2 times positive 1 is 2. And now to evaluate this 2 by 2 determinant, we would have 4 times 3 and minus negative 7 times negative 2. 4 times 3 is 12, minus negative 7 times negative 2 is positive 14. So, simplifying inside the parentheses, first, we have 6 times 2 times 12 minus 14 is negative 2, which gives us 6 times negative 4, which equals negative 24. So, the value of the 4 by 4 determinant in this question is equal to negative 24.